Hi, this is Sung. I am your online maths mentor, and we've been going through the topic of permutations and combinations, right? Which is all about counting arrangements or selections or counting groups, right? And we've gone through a whole lot of stuff. We've gone through permutations, and in the last couple of episodes we've gone through combinations. Combinations being all about selection, okay? All the different selections that we can make from a bigger group, okay? Now, we worked out that the formula, all right, or the general way of working out how many selections there are from a bigger group of n, where you choose R objects out, right, to form another group, right, will be equal to n factorial all over R factorial times n minus R factorial. Okay, so that's the general formula. And so basically, if you are to choose, as an example, 7 objects out of a group of, say, 10 objects, there will be 7 combination choose 7 ways, or sorry, 10 combination choose 7 ways of selecting different groups. Okay, that's how many groups there will be. So that's basically the general formula. However, I want to say that there are some common variations. There's some variations on combination calculations that we need to go through. Okay, now let me just, because this is the subheading, let me just underline that. So let me go through some common variations, right? And I've got some questions to go through that will help us go find those common variations. They are multiple grouping or multiple groupings, the addition principle, or you might have to use the addition principle to work out some combinations, where you might have restrictions. And then another example is where you might have, or where you might do some selecting and then do some arranging, right? Which means that you have to use a combination of combinations and permutations. Yeah, there's a mouthful for you. So there are a couple of different variations or common variations on combination questions. So let's go through some of them, right? I've got the first one up here, right? Says this: how many ways can 6 men be partitioned into groups of 3, 2, and 1? Okay, so to do this question, you've got three groups, right? So you've got this group here, which has 3 positions in it. You have this group here, which has 2 positions in it. And then you have this group here, which has 1 position in it, okay? And the way you do this particular question is you do this. You've got this group here where you can choose 3 people from 6, yes? So how many combinations will there be where you can choose 3 from 6? Well, the answer will be 6 choose 3. Does that make sense? Which leaves us with how many people left? Well, after we've chosen 3 from the 6, we've got 3 people left, right? 3 people to fill, all right? 3 people to fill 2 spots. So here we've got 3 choose 2. Does that make sense? And then finally, for this last spot here, we've got 1 person left, so it's 1 choose 1, okay? Which is just 1 itself, all right? There's only one way that you can choose 1 person to make another group, okay? So you got 6 choose 3, 3 choose 2, and you've got 1 choose 1, okay? Let's multiply that, because here we're using the multiplication principle, all right, to do multiple groupings, all right? So when you've got multiple groupings, you multiply and then put those numbers into the calculator, and that should actually give you an answer. So let me just pull out my trusty calculator, work this out, and then I'll write the answer up on the board, okay? Hold on a tick. So your answer will be 60, okay? Good. Now, here's something for you. Do you think the answer will be different if we filled up this group first, right? So in other words, let's fill that group up first. You should have 6 choose 2, which leaves us with 4 people left, right? Which means we can fill this one up, and that would be 4 choose 3, followed by 1 choose 1. Will that be the same thing? Will that give you the answer, the same answer? Well, the answer is yeah, you would expect that it does. And if you put it into your calculator, you will work out that that is exactly right. Okay, good. Now, it just makes common sense that that would be the case, right? But apart from common sense, go away, have a think using this formula, or using this, what we know about this formula, have a think about why this would be true from a mathematical point of view, not just from a common sense point of view, okay? That'll be an interesting exercise for you. Now, will it be any different if we were to divide the 6 men into 3 groups of 2, all right? So in this case, what we have is something different. You've got a group of 2 here, you've got a group of 2 here, and you've got a group of 2 there. Now, the way we approach it will be exactly the same, all right? How many ways are there of picking the first 2? Well, there will be 6 choose 2, which leaves us 4 left. How many ways are there of choosing the second 2? There's 4 choose 2, okay? Because there's 4 remaining, and then the last one is 2 choose 2. Multiply those together, should give you an answer. Let me work it out using my trusty calculator. And this time, your answer is 90, okay? Good. So does that make sense? All right, so there's some of you there thinking, hang on a tick, I know the answer is 90, but I can actually see that there's something else going on, yeah? Unlike this example, there is something else going on here, and that is this. Right? This is the sneaky bit. With something like this, with these 2 groups here, with these 3 groups of 2 here, so in other words, these 3 pairs here, right? What we can see is that there will be 90 if this pair, and this pair are ordered, right? So they're arranged in some order. So this is the first group, this is the second group, this is the third group, and that's the way it will always be, right? But if we're just dividing the 6 people up into 3 groups of random pairs, then what will happen with this particular question is that the orders of these groups won't matter, okay? So if you had A, B, C, D, and E, F, right? Whether we kind of swap the order around, it wouldn't matter. But what we've got here is 90 arrangements where the order does matter. So what we've got to do is we've got to divide by, I'm going to take this answer and divide by, all right, so it's 90 divided by the number of arrangements of 3. Okay, which is 3 factorial. Okay, so we've got to actually divide by 3 factorial, which gives us an answer of 15. Okay, 3 factorial is 6, 90 divided by 6 is 15. Okay, good. So you don't quite get the 60 groups that you want. You only have 15. But hold on, all right? Some of you might be thinking, why don't we do that for this example? Why don't we also divide by 6 factorial here? Because, the answer is because these 3 groups can't be confused with each other, right? So the reason why we don't divide by 3 factorial for this question here is because the groups have different numbers in them, right? You've got a group of 3 here, a group of 2 there, a group of 1 there, and so each arrangement will also be a unique combination, yes? Whereas for these questions here, each combination will have a number of different arrangements to it, okay? Good. So that's basically this question here, question 1. So we've basically done multiple grouping, yep, that particular aspect. What I would like to do now is have a look at question 2. All right, let's have a look at question 2. Let me rub off this side of the board. Now, question 1 is, what was it, 60? And question 2 was 15, yeah? Now, let's have a look at this particular question. Question 2. It says a class containing 20 students with 7 being female are selected to form a committee of 6, of which there are exactly 2 females, right? So how many different ways are there of combining them, or how many different combinations are there? Well, this one will be similar to the grouping within, the multiple grouping questions. What I would do is set aside one group of 2 here, right? And one group of 4 here, right? Now we know that in this group, there has to be 2 females. We can choose from a possible 7 females. So what we have here is 7, choose 2. Got it? All right. In this particular subgroup, right, we can have, well, there will be 20 students, of which there are 7 female, which means that there's 13 males, right? So of the 13 males that are remaining, 4 of them have to be chosen for the committee, so it's basically 13 choose 4. Got it? Yep. So it's 7 choose 2 times 13 choose 4, which will give you an answer, and we get an answer of something ridiculously big, 15015. Do you see that? Good. Now, here's what I want you to know. The next question is going to be a little bit different. Okay, it's going to be a little bit bigger. Okay, the next question says, how many different ways or how many different combinations are there where there must be at least 2 females in the group? So we're not looking for exactly 2 females, just like it was in part A. We are looking for at least 2 females. So let's have a look at how we would approach that. Okay, hold on a tick. Let me just rewrite this. So in this particular case, it was 7 choose 2 times 13 choose 4, okay, which is 15015. So for this example, let's choose part B. What we have is we need to work out how many committees can be formed with at least 2 females. So this is what we're going to do. We're going to find how many committees there are with exactly 2 females. So 2 females. Right, which means that there must be 4 males. All right. We can also do the same with 3 females, and that will be 3 males, 4 females, 2 males, 5 females, 1 male, and then 6 females. So we want a group where all of them are females, which means that there's 0 males, and that might be all there is. Okay. All right. All right, so you got 2 females, 4 males, 3 females, 3 males, 4 females, 2 males, 5 females, 1 male, 6 females, 0 males, and all of those added together, yeah, you would have to add them together, would give you all the committees that you could make where there is at least 2 females, right? Because all of these, all right, satisfy this larger condition. All of these conditions satisfy this larger condition. All right, so let's work that out. 2 females, 4 males. Obviously, it's 7 choose 2 times 13 choose 4, which we worked out over here, which was 15015. This one here is 7 choose 3 times 13 choose 3, right? 7 choose 4 times 13 choose, and here it would be 7 choose 13 choose 2. 7 choose 5 times 13 choose 1, and then it would be what's this? 7 choose 6 times 13 choose 0. Now 13 choose 0 is going to be 1. All right, so basically we worked that out. Once we worked out each of these numbers, what do you think we have to do to work out the total number of groups where there is at least 2 females. Like I said, we add them all together. All right. So let me just work these out on the calculator, and then we'll find the answer, shall we? So I've worked out all the all the calculations for each of these combination expressions. So now all we have to do is add them all together, find the grand total sum of it all, and that will give us our answer. Our answer is 28035. 28035, all right? So there you have it. That's how you do this question here. Okay, good. All right, I'm going to now, so we've done the addition principle now. I've got 2 more questions that I want to go through with you. Restrictions and then selecting, then arranging. All right, I'm going to rub off this side of the board, come back to you with some brand new questions, and we'll continue once that's done. All right, thank you very much for watching. Hi, welcome back. And so in this episode, what we're going to be doing is we're going to be looking at some more variations on combination calculations. All right, again, there's a mouthful. But let's start off with some restrictions and selecting and arranging. Okay, so these are the last 2 that we need to kind of cover. By the way, it's not an exhaustive list, 1, 2, 3, 4. It's not like that's the be all and end all. But they're just some common ones that I think we tend to encounter when we do combination and permutation type questions. All right, so let's have a look at question 3. All right, so part 1 will just be kind of like a warm-up exercise. So question 3. All right, how many different ways can a committee of 3 women and 4 men be chosen from 8 women and 7 men? Well, okay, so we're choosing 3 women from 8 women. So it's 8 choose 3 times, and then we're choosing 4 men from 7 men, 7 choose 4. Got it? Put that in your calculator. That'll give you something neat and tidy and probably quite big. It'll give you this number here, 1960. Got it? Cool. So that's that one. Now, this is where the restriction part comes in. Right? So we've just done like a multiple grouping bit. This is where the restriction comes in, right? How many ways, if woman A refuses to be on the committee, if woman B is also selected? Now, for those people out there who might be offended by this question, it wasn't deliberate that it's women. It's just kind of that's basically the way the question's worded. It could just as easily have been a man or woman, man A and woman B or whatever. But that's just the way the question's worded. How would you do this? All right. Basically, this is what you would do. All right. Here's how I would do it. I would take this number, which is the total number of combinations that you can have where you choose 3 from 8 and 4 from 7, all right, with females to males. And what I would do is take into consideration all the different ways that you can create this committee where A and B are together, right? Where A and B are together. Now, by doing that, what would that allow us then to do, right? It would then allow us to find the complementary, right? Which is basically the total number minus the number of combinations where A and B are together, and that will leave us with all the combinations where A and B aren't together. Does that make sense? Okay, beautiful. So there we go. So for part 2, our answer is going to be this 1960 minus, or how many different ways can you choose the committee so that A and B are in the committee together? Well, here you've got A is a woman and B is a woman, all right? So in other words, if A and B must be on the committee, then you're basically choosing 1 extra woman from the other 6 women. Does that make sense? So basically it's 6 choose 1 times 7 choose 4. Got it? Yeah. Hopefully it does. Because basically what that's saying is we're basically anchoring woman A, woman B which leaves 1 other position for 6 other women, right? And then 4 other men from a pool of 7 men, okay? And that's when A and B are together. That's the total number of combinations. Take one away from the other and that should give you your answer, all right? So basically what we got is 6 times, which is 1960 minus 210, which gives us 1750. Got it? Beautiful. So now, what have we done? We've done this one, restrictions. Restrictions is out of the way. The last question that I want to do involves basically bringing together our understanding of combinations with previous work, our understanding of permutations. Okay, so here's what we've got. How many ways can 4 men and 3 women be arranged in a row? All right, see arranged, see the word arranged? Yeah, so we should be thinking permutation if 8 men and women, if there are 8 men and 5 women to choose from. Okay, so first of all, how many groups are there? The number of groups that there will be, or in other words, the number of combinations there will be, the number of ways that there will be, is 8 choose 4 times 5 choose 3. Does that make sense? Because we're choosing 4 men from 8 men, and then we're multiplying that by 3 women from 5 women, okay? So that'll give us the number of, what? The number of combinations, yeah? Right, now what we have to do is multiply that, yes, by the number of arrangements. And how many arrangements will there be? Well, if we're choosing 4 men and 3 women, there's going to be 7 positions in the row. Does that make sense? There's going to be 7 positions in the row. How many ways can you arrange 7 people into 7 positions? Well, it's going to be 7p7, right? Or another way of writing that is 7 factorial. Got it? So that is basically another common variation for this type of question, where you first have to select and then you have to arrange, okay? So let's work that out. Let's work that out on the calculator, which gives us a whopping great big number, 3, 5, 2, 8, 0, 0, 0. Okay, good. Now, before we finish up, I basically just want to say that in terms of permutations and combinations, that really is the nuts and bolts of it, okay? There is a little bit more of permutations and combinations to go, but I'm going to cover that specifically in another topic called binomial probability, right? Where we will look at what we call combination proofs or combinatoric proofs, right? And we also get to see how combinations is related to binomial expansion, right? And that'll become clearer when we do that topic, okay? But for the time being, really, this is all there is for you guys to know for permutations and combinations. In the next episode, I'll do a summary to just kind of wrap things up, yeah, and just to give you everything that you need in order to do what you need to do for this particular unit of work. But I just want to thank you for watching, and I hope that it has made sense all the way throughout. Okay, see you later.